Hello, everyone. Let's see if it works. So my name is Meriem Bendris. I'm a solution architect manager at NVIDIA. I'm based in France, and I mainly focus on helping NVIDIA partners and customers building AI systems, mainly focusing on training, fine-tuning AI models, different type of models, LLMs, vision models, speech models, and so on. Okay, so that works. And today I'm here to talk about something slightly different. Okay, so let's have a look. So I'm going to show you how you can build your AI agents and deploy them locally on your machine. So I bring with me a DGX Spark here. So I will show you how you can actually deploy, and we will show you some demos, nice demos on how you can do that. Also, due to power issues that we are having on stage, so we will not be able to do that live, but I would invite you to come to see me actually after the session, and I will show you that in live, hopefully. All right, so for people who are not, who have never heard about AI agents, basically, when we talk today about AI agents, we usually talk about two actually main components. So the LLM itself, or a language model that will allow us to interact basically as a human being with the machine or with the agent, and the harness. And the harness basically is all the operational system that will allow us to execute our agent. So it is based in different components usually. So it has a context that could come from the memory. It will observe actually what is happening in the memory, but also from the prompts of the users basically. It will be able to orchestrate the requests. It will reason from the requests that the user will have, and it will act on it. And to act on it, it will need to be equipped with skills, basically, and tools. And those tools could be language models. It could be even the same language model that we are interacting with the agent, but it could be also other type of models, other type of skills, other type of tools that we can have, like math solvers and so on. So this is basically, today, when we build AI agents, we need those two components, right? So again, if you're not familiar, so maybe just like to give you a quick overview of how AI agents evolved over the last few years. If you do remember basically the ChatGPT moment, at that time the models, the AI models or the LLMs that were behind the scene were trained mainly for multi-turn chat conversations basically. And then from that, we started to evolve the LLMs and the way we are building the AI agents to go from chat, multi-turn conversation to more models who can act, who can solve tasks and sometimes very complex tasks. And if we think about the LLMs, for example, that are behind the scene for those like new era of AI systems, so we literally now changed or augmented the way we are training it using a lot of techniques such as reinforcement learning with verifiable rewards, where basically we can, if I can summarize it, where we have in many cases machines who are actually teaching other machines to improve their quality to solve tasks. So now we are in that era where basically those models are equipped, or like those agents are equipped, and they can actually act. They can reason, they can plan, and they can solve very long, complex problems. So that's, the slide says like agents go to work. I have two examples to show you here, for example. Let's say, how many developers do we have in the room? Like just like, oh, here we go. I see that most of the audience are not developers. Let's say if I had a task and I'm not a developer, and I'm asking like, make a JavaScript Newton's cradle animation in a single HTML file. So that's the input basically. And an AI agent today will be able to understand, to reason, to plan, but also to generate the code. Maybe if it is not equipped actually with code generation, it will ask other models to do that on their behalf, and it will generate that animation. So let's see, this is the first animation that I'm having. Let's see if it works. Here we go. Oh, it went too fast. Here we go. Ooh. All right, so what you can see here in the animation is that we have the agent who is reasoning. Here we go, and then you had, oh, that's the second one. Let me come back to the first one. All right. Oh, here we go. Let me see it now. Here we go. So I hope you can see it. So now, if I'm not actually a developer, I don't have any skills as a developer, with this type of AI agents, I will be able to actually in few lines of codes, or just like communicating with my agent in a natural language, and it will be able in few seconds to generate this type of things. The second example that I had, I like that one because actually it's very specific. I'm asking it to create an animation with an NVIDIA green dot on a black scatter from Taipei 101 building. That was during the GTC in Taipei that we had a few weeks ago. And then morph it to GTC Taipei 26, and then morph it again to NVIDIA. So hopefully you can see the animation now. You've seen it here. So again, with no code capabilities as a human being, if I'm not a developer, I would not be able actually to generate that. And today, everyone actually can do it. All right. And there are different libraries today that will allow you to build this type of agents. Some of them are open source, and today I would like to talk about OpenClaw. OpenClaw actually is an open source library that will allow you very easily to build persistent systems or persistent agents, very easily equipped it with different skills like having access to your emails, for example, manage your calendar, book flights and stuff like that. But also you can get your notification and you can actually control that via different channels like WhatsApp, Telegram, Slack channel, and so on. So, and it will have access to your file system, so it will be able to actually create folders, create scripts, for example, in your folder, edit some code, and so on and so on. So actually, this OpenClaw project, I think it was released in November or something like that in 2025, and it very quickly started to be a de facto library to use to build AI agents. So let me actually show you, hopefully the video will work, how fast the adoption of OpenClaw was. Okay.
An open source project just dropped.
Andre Karpathy has just launched something called Research is a huge deal.
You give an AI agent a task, go to sleep, it runs 100 experiments overnight, keeping what works and killing what doesn't.
I really love what my stuff enables that person to do. And we had like one guy, he told me like he installed it at his 60-year-old dad, and like they made beer, connected the machine via Bluetooth to OpenClaw. And then we automated everything, including the whole website for people to order.
Lobsterlager fertig sein.
If you like beers.
Everyone is talking about OpenClaw.
OpenClaw. We want to build OpenClaw with OpenClaw.
What is OpenClaw?
Hundreds of people are queuing up for lobsters in Shenzhen.
Believe it or not, there's already a claw con.
All right, so this video just like to give you actually a sense of how popular was that library to build AI agents. So if we go basically to the demo itself, so what I would like to show you is literally how you can run OpenClaw on open source LLM. So I will be using Quen model, for example. It's a 35 billion parameter model, a mixture of experts, so 3 only active, on an NVIDIA DGX Spark. So you have one here. If you are not familiar with the DGX Spark, I will give you a very brief introduction. And by the way, just like the picture here is with the founder of OpenClaw at Vivatech 26, that I was showing him the same demo. All right, so DGX Spark is NVIDIA designed architecture to build and run AI models. So it's meant to be literally on a desktop, basically. It has a large local memory. It supports a bunch of NVIDIA software support stack. And if we want to have a look at the accelerator itself, so it has a GB10 Grace, so GB for Grace Blackwell superchip. So it has 20 core ARM CPUs, so that's the Grace part, and it has 120 gigabytes of memory. That memory is GPU and CPU shared, right? So that's a DGX Spark. The way we connect it is very, very easy. I think we've been doing that for a while here, trying to make it run on, on stage. But basically, it has, very briefly, you know, like a power USB-C. It has some USB-Cs as a system connections, an HDMI port, and the network, basically. It's quite easy to kickstart, running your AI workload on a DGX Spark. So now that said, so due to some limitations of the power that we had here, so I recorded the demo, and I recorded the demo 2 days ago. So I'm saying that information because it will have an incidence in one of the requests that I was doing. And I actually took a picture of myself on recording that demo. All right, so let's see, let's have it. So I had my DGX Spark, so I installed already OpenClaw. I downloaded the Quen model, I deployed it, that's it. And then I just did one extra thing, is that I linked it to an AI mail agent, and also I just changed its name. I called it Claw, right? And then from that, so as you can see here, so yeah, here what you can see is what is happening on the GPU. So now I'm just waking it up. Here we go, and asking it when is the next GTC Berlin happening. And as you can see, it automatically went to search on the web because I give it the credentials to do that. And here we go. So we have the information, you know, GTC Berlin 26 will happen in between 20 and 22nd of October. So, and you could see, you know, monitor your GPU to see what is happening there. You could have also a look on the OpenClaw, the information about your tokens, the dollars, the cost. It doesn't cost anything in terms of API calls because everything is running on the machine. And now I ask it the question, and I will stop here for a second because that's basically what changed since yesterday. I asked it the question to list actually all the World Cup football games where France was playing and to give me the scores. And it was giving me the list. That's what you can see here, searching for on the web first, and then giving me the list. And as you can see here, the next one was France versus Morocco. Sorry for the Moroccan, you might have known, maybe if you've seen the game yesterday. So we have a new score. Okay, and now because I know exactly who is my friend is called Meriem, and I know she's French, so I'm just telling, send an email to wish her good luck to her team, actually. And that's it, here we go. It says it's done. We can go and check in my emails. Here we go, I received an email that was automatically sent by OpenClaw. Right, so let's see. Now I switch a little bit and I ask it actually to do something that would actually be done periodically, like every day or every month or every week. And what I asked it to do is to fetch actually the technical blog of NVIDIA and to send me a summary of the top 5 news, and to do that every day. I think that's what I did here. And I give it actually a time. I think it was 9:30, something like that. It asked me actually what time zone was that, so I said like CET, okay? And now what you can see is that it will actually reason first, understand that this is something that needs to be scheduled, and it will generate that schedule. That's called NVIDIA Block Daily Digest. And as you can see it here, it will say that the next one, it will happen in 22 hours. I said like, I want one now, right? Don't start from tomorrow, start from today. And that's exactly what I said, like, okay, please start from today. Here we go. And then give it a few seconds, and it will tell me that it's gonna do that, fetch the NVIDIA technical blog articles. It will summarize the top 5, and here we go. Give it a second, and it will send me actually an email with all the information that I asked. Second thing that I started to do is to play as a developer or a non-developer. I like to play video games, so I just ask it, can you write an HTML application that have a Pong game and save it on desktop, right? And the name is Pong, okay? So that's for people who like to play video games. So it's a very simple. Oh, by the way, I'm just showing the email that I just received, you know, with the digested articles. Here we go. I just like open one. Coming back here, so sometimes it might take time if the task is a little bit complicated, if it's complex. So it's not just a chat, really reasoning, doing stuff. So sometimes you have to be patient and do something else, or ask it to do something else at the same time. So here I'm just like showcasing again. Here we go, give it a few seconds. And it should actually generate, here we go. And it should generate at some point here we go. So it tells me it generated it, yeah. And here I'm opening it, that's a Pong. It took me a few seconds to understand that for the left one, I had to use W. So you will see it here. But that's here we go. So that's basically it. And then I said like, okay, so I have a new like HTML file that OpenClaw just created on my desktop, but I want to modify it. So I just ask it, can you put the background, change the color to NVIDIA green color. So notice I haven't even said what is NVIDIA green color. And you will see that it will trigger, it will search in the internet, again, because I give it the access to do that. And then it will change the background to NVIDIA green. Give it a few seconds. Here we go. I'm updating now. Yeah, green, right? So with no developer capabilities, I could do that without any programming, basically. Right? Okay, coming back, and you will see that actually it triggered exactly what is the code for the NVIDIA green. Now I'm asking it more like 3D design. So I asked it actually to draw a spinning 3D cube with HTML and 3GS. And I didn't say anything about the color, by the way, but it took some, you will see the results, and it took some initiatives. Again, let's see. There we go. Here we go. And it did actually the cube, but it took the initiative to keep it in NVIDIA green. I didn't ask for it, but that's exactly it, right? Okay. So the last demo was more like trying to give it more complex tasks, like generating video games, but like complex games. So let's see how it goes. All right. So the last one is like write me a 3D Mario Kart game, right? In HTML and 3GS, and put that on desktop/code/Mario Kart. So it will trigger, if we have a look, actually I could have opened actually the reasoning there. So you will see that it checks first if it exists, if the folder exists or not. If not, it creates it. And after a few actually minutes, because it took a little bit of time, I had the first iteration. Well, it looks like, but I mean, like, that was just like the first prompt. And now the idea is that you can iterate, you can modify, you can ask it to add stuff, to make it more pretty and so on. All right. So that's it for me.
We have time for a few questions, right?
Yeah.
It's for Meriem. Who has a question? Who wants to book for a question? 2 books.
It was very clear.
I think, sorry?
It was very clear.
It was very clear. So who has an open claw? Who has a claw or Hermes or whatever? So first, who has an open claw? Okay, open claw.
Okay.
Who has a Hermes? Hermes app?
Oh.
Come on, you raise the left hand when I say open claw and the right hand when I say Hermes. Okay, good.
Any other tools? Oh, sorry.
No, please.
Yeah, any other tools are you using?
Which
No?
one? Pi?
Pi?
Okay, Pi.
Yeah. Okay,
What are the
amazing.
tools?
Yeah. Perhaps NemoClo? No? Okay, so maybe I can say a word about NemoClo. Yep. So NemoClo is an NVIDIA software stack on top of OpenClaw, but not only OpenClaw because it supports different harnesses, where we are trying to add an enterprise-grade solution on top of this type of tools that would give actually controls. Because I don't know if you have noticed here, but actually I give the total control of my machine to OpenClaw. So it will be able to go, have access to my file system, delete some files, and so on. And basically, for enterprise-grade solution, we want actually to constrain that. So usually, we build a kind of sandbox, basically. We use OpenShell for that. And we add some controls in terms of compliancy, what the agent can do, what it cannot do, and what it should ask for credentials or approvals before doing something. And the fact that it is containerized solution, it won't touch, destroy everything, so it is running in controlled environment. So that's another area where at NVIDIA we are working on.
Thank you, Meriem. Thank you very much. Yeah.
And again, maybe just to say that I will be actually on the area where we are having the
cocktail.
Yeah. So if you want to see the demo live, please just come in and I will show it to you. Hopefully. Thank you so much.
Meriem. Thank you.